Hello and welcome to today's daily Leetcode challenge. Today we'll be solving another question, going through my thought process, and then at the end of the video comparing my solution to the solution of others to see where we can improve my solution. With that, let's begin question 459, repeated substring pattern. Okay, given a string S, check if it can be constructed by taking substrings of it and appending multiple copies of the substring together. Okay, so in my own words, I'm giving a string S, and I have to see if that string S can be created or constructed using at least two substrings. So, meaning if there's a pattern within it that repeats over and over again, and at least twice, then the output should be true. Otherwise, it should be false. I think it's pretty self-explanatory, and the examples here are also pretty vivid. We have a string AB and AB. And we can see that we can take AB substring twice to get the whole string. Example 2, we're given a string ABA. The response is false because there is no substring in S taking multiples, by which taking multiples of that substring would equate to the input S. Right? We can't take AB and take it multiple times to get ABA, and single characters don't work either. Lastly, we have an example here, which is called ABC, 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 and we can see that if we take ABC, however, 4 times, then we can actually get the input substring. The input string. Okay, well, with that, I think we're ready to start thinking about the solution. So, probably the most intuitive way for me to do this would be, and the solution that I would gravitate towards most would be something like me iterating over the input string and trying to construct this substring value. For example, I would probably start iterating this input string, starting with A and B, and then have some variable substring that is created as I'm iterating through it. And then upon reaching the end of my substring, I would maybe think, okay, well, can the next couple of characters in this input string be at the actual substring itself? And I mean, that sounds like a good initial solution, but the problem there is you can run into something like a local minimum where you might be looking at a beginning of the substring that you've already created as you're iterating through the rest of the string, but in reality you might just be extending on the substring itself. So what if we scratch that idea and we utilize something like, for example, what if we utilize Python string comparison methods? I was thinking that, let's say we only explore half of the input string length. In this case, since there are 12 characters, we'll be exploring the first 6, and we will try to see if the string, the whole input string, can be constructed out of initially the substring of just consisting of A. If not, we'll try creating it out of the substring AB. And finally, when we hit AC, we will see that the whole string can actually be created from the substring ABC. That way, we don't have to iterate through the whole string, first of all. And second of all, we don't fall into these local minimum where we could be looking at maybe like, we could, for example, here, where we have A, B, A, B. What if this one had a C right here? And we would think that this is here. This is what I'm talking about. A, B, A, B, C, A, B, A, B, C. Do you see how here, in my initial approach, I could have assumed that AB was the substring, and then this would have fallen into as if being a substring, and then this one would have prevented the previous assumption that AB is a substring from being true. Okay, well, with that, let's begin the implementation. I think that I have a good idea of how to write the algorithm. Let's have length be the length of the input string, and then what we're going to do now is explore the first half of the input string. And for I range, we're going to explore the first half of the string like this. I is going to be the end of the substring. Then we are going to have if L modulo end sub str is equal to 0, so that basically if the substring that I'm currently looking at divides the length of the whole input string evenly without there being any remainders. That's critical because after this condition, I'm considering my substring to have to be able to make up the whole input string. And since I'm able to make up the whole, if I'm able to make up the whole input string, it means that it fits in there evenly. Substring is going to be now equal to S from beginning to end substring. And finally, and now I make the comparison. If I have found my substring, if I can multiply my substring times the number that substring length divides the input S into, then I can return true. So if sub str times length of L divided by, and this divides it into even numbers, so if I divide it by this, return true, return false. So if given that I've found a where do I have N? L. If I found a substring that taken this number of times gives me the actual string, then return true. Otherwise, return false. End of sub str. Misspell that. Sub str. There we go. Okay, yeah, this is this is pretty easy, but I wouldn't call this like a very easy to get to solution. But anyway, yeah, this doesn't even beat a lot of solutions. But let's see where I stand here. This is our solution. Again, the idea is that I'm going to explore all the different possible substrings that I could potentially have. All the different substrings potential have to be at most half of the input array. So if the input string, if the substring doesn't exist in the first part of it, then we automatically know that it's false. Now that we are exploring the first half of this input string, we have to see what are the different ways each one of those initial substrings can make, what different ways can it make up into the whole string. And I have a condition here to initially filter out the substring lengths that won't even make up the whole string. Then, if this condition passes, it means that the substring at least divides the whole input length into even splits without any remainder. Now that I have that substring, I simply multiply that substring, so repeat it the number of times to make up S. And if the two strings are equal, then return true. Very easy submission we have here. Let's now look at a comparison of my solution and others. Currently there's just one faster, and what are they doing here? They are, okay, I see what they're doing here. They're joining two of the input strings together, and then are they just, yeah, and then they're removing the first character and the last character, which doesn't affect the pattern within the string itself. And then if there is a pattern, they're seeing if the input string S is in the joint string. So in other words, they are doing something like this. Join is equal to S plus S, and then they're taking the -1, print join, and then they're seeing if S is in that join. Perfect. And then they're saying return S and join. Another quick solution. Yeah, let's see if this one's faster. Yeah, just play around with this. I think seems to be a lot faster, but still not the fastest. Although, yeah, it doesn't seem like we're gonna be beating this any better. But yeah, with that, thank you for watching. This was a quick and easy one. So, yep, thanks for watching. See you later. Bye.